Hi, welcome back to General Chemistry 1. I'm Dr. Fang Xu. Let's talk about atoms and isotopes. In the last video, we discussed the structure of atoms, and we know there are many atoms in nature. As we want to be a very organized person, we put these atoms into a table called periodic table. And these atoms are put in the sequence with the increasing number of protons in the nucleus. So you can see here from the atomic number 1, 2, 3, 4, 5, which means these 5 different atoms has the number of protons of 1, 2, 3, 4, and 5. And it only indicates the protons in the nucleus. So from this, we directly know the number of protons by identifying the atomic number of certain atom in the periodic table. In the atomic structure, we not only have protons, but there are also neutrons and electrons, right? So we need to use the atomic symbol to represent what exactly type of atom we're talking about. And here is a symbol of the atomic symbol. We use X referring to the atomic symbol. Basically, if we have a carbon in this case, we put a C there. And A on the left upper corner is the atomic mass number. Mass number means how much does this specific atom weigh? And it can be calculated by using the number of protons plus the number of neutrons. In this way, we get a mass number in the unit of U, the atomic mass. In the lower left corner, we have the Z, which is the atomic number. We discussed it before. We can find this number in the periodic table. Here are 2 examples. So for this atom, it has 6 protons and 6 neutrons in the nucleus. So according to the 6th number of protons, we can identify that in the periodic table as the element is carbon. So we put C to replace the X here. The mass of this atom can be calculated by using the 6 proton plus 6 neutron. In total is 12. Remember, the electron does not weigh that much, so we can ignore that. Here's another example of oxygen. From the 8 protons, we identify the symbol of the atom as oxygen, the O, and then put 8 in the lower left corner to representing the 8 protons, and 16 on the left top corner to representing the total mass. 8 plus 8 equals 16. From this, we know that the number of neutrons equals to the mass number of an atom minus the number of protons. Because neutron cannot be directly seen in this atomic symbol, and we can use this equation to calculate that. Or neutron N equals to A minus D. This is the equation to calculate neutrons. In general, we combine that equation with a few others. Protons equals to the atomic number, and for atoms, which is charge neutral, the number of protons equals to the number of electrons. Please pay attention to that. Mass number of protons and neutrons in an atom must be an integer. You cannot have 1.5 protons in an atom. It has to be an integer. All right, let's take a look at a question. How many neutrons are there in the atom ATBr? And how about the number of electrons? From the periodic table, we know Br is bromine and has an atomic number of 35. The atomic number equals to the number of protons. So the protons equals the atomic number equals to 35. This is something we can find in the periodic table. Then it asks how many neutrons are there. We can use this equation neutron equals to the mass number minus the number of protons. In this case, mass number is provided, 80, minus the number of protons, 35. The answer for neutron is 45. And electrons has an equal number with protons because it's an atom, it's charge neutral. So number of electrons equals to number of protons equals to 35. This type of question will be seen in the exam. All you need to know is these three equations. There's a reason why the neutron is not seen in this atomic symbol. One thing is it's reflected in the mass number. And the other thing is the neutron can be changed for one type of element. And we call those isotopes. Isotopes are atoms with the same number of protons, but different number of neutrons, such as carbon-12 and carbon-13, if you are familiar with this too. And because we have these isotopes, different isotopes have different mass number, 12 and 13. What we found in the periodic table, the atomic mass in the unit of AMU, is an average of all of the isotopes of the same element in nature. So that's why you will find these like 35.45, which is not an integer, although the mass number for each atom is an integer. Okay. And despite they have different neutrons, carbon-12 and carbon-13 are all carbons. They belong to the same element. Let's take a look at the question. Determine the number of protons, electrons, and neutrons in titanium-46 and titanium-47. It's actually the same thing as before. You just need to memorize or master that three equations. Once we know the symbol titanium, we can find in the periodic table the atomic number. Here is 22. That means the number of protons equals to the atomic number, that is 22. Then the electrons equals the number of protons. Electrons carries one negative charge, proton carries one positive, and an atom needs to be charge neutral. So that's 22. Finally, we need to find how many neutrons are there. Neutrons equals to the atomic mass minus the number of protons. So for titanium-46, it equals to 46, the mass, minus 22 equals 24. And for titanium-47, the number of neutrons is 25. This is the end of this video. See you next time.